Great that you all could make it here. I'm very excited for this talk. So this talk will be shared between Barnabé and me. I'll start, and then Barnabé will take over. And I wanted to start with a quick recap, right? Like, what does protocol even mean? I mean, we all know the word, but like, what does it mean in this context? And so specifically, throughout this year, there were a few changes at the EF, and you might or might not have seen this blog post that was late April of this year by our new executive directors, Xiaowei and Tomasz, that basically outlined as part of the kind of the focus for the coming year, these three priorities, specific focus areas for the EF: scaling Ethereum mainnet, scaling Blobs, improving UX, with this kind of addition, including interop application layer. And that really kind of kickstarted internally as well. We have a lot of technical teams in different places in the EF, some sort of like thinking about how can we best structure ourselves to deliver on these priorities in particular. And so a month and a half later, there was an official kind of adjustment to the organization of these technical teams, and that was the beginning of what we call the protocol cluster. So the protocol cluster is the group of most of the technical teams at the Ethereum Foundation. And in that blog post as well, you see again this kind of like, by now it was a bit more concise: scale L1, scale Blobs, improve UX. And I wanted to just basically give a bit of a status update. What have we been doing? We are now 6 months into that 12-month focus time window. What have we been doing in those 6 months? What are we going to do in the next 6 months? Where are we at? And so I'll talk about the first two here: scale L1, scale Blobs, and then Barnabé will talk about improve the UX. First, though, I wanted to briefly have one more like way or two more quick, just like mental models for you to maybe like consider in terms of like how are these three priorities somewhat different. The first one I would say is, to what extent were they existing focus areas at the Ethereum Foundation? And so scale L1 was in some ways existing because we had this existing focus on ZK EVM as the long-term big upgrade that will help move Ethereum throughput to like really exciting levels. But what was new here was the attention on the near term, basically saying, hey, before we get there, what can we do? Scale Blobs was really much more saying of, hey, we've been doing this already over the last few months. Let's really communicate clearly to the world that this is a big priority, and we'll continue to focus on this and deliver here. And then improve UX was new, not in the sense, of course, Ethereum UX has been a big topic for a long time, but basically rethinking a little bit what can the role of the EF as a coordinator in the ecosystem be here. So that's mental model number one. And then mental model number two is, maybe you are aware of this kind of this idea of like 0 to 1, right? Creating something new. And ideally, you read the slide from bottom to top here. So basically, UX, again, it was about what should the role of the EF here be. So it was much more of like a 0 to 1. It's like coming up with a strategy, like tying all these individual pieces. UX is a very broad topic, tying it all together. And then scale the Blobs was a 1 to 10. We already had the existence proofs. We had already deployed an early version of this. Now it was about scaling this. And then, of course, mainnet itself, Ethereum L1, has been around for a while. And so the idea was primarily, here it's much more about a continued kind of bringing this to even more mature production. So those are the general kind of considerations, and then I want to start by going into scale the L1. So what was the situation? The situation early this year was that the gas limit, that's how we measure the total throughput of Ethereum, had not been changing for close to 4 years. So ever since early 2021, it was before ERP 1559. For those of you that are familiar with these technicalities, it was 15 million, and then with 1559, we added this like 2x factor between the target and the maximum, so now it was 30 million, but ever since, basically, we had been at 30 million. And why was that? Well, because the engineering focus was on other really important things for Ethereum. That was first the merge, then it was really interesting new features. Just the fork before, we shipped ERP 7702, for those of you that have maybe started using these smart accounts, really amazing features, but a different focus. And then, of course, the robustness of the chain is always a top priority for Ethereum, so that also took a lot of attention. And we already had a long-term plan, right? So Ethereum already had this plan, ZK EVM, eventually there will be a big upgrade. What was new now was basically to say, hey, we also really want to focus on the short term. What can we bring to the chain now? And in particular, it was really interesting. There was an organic push by the community earlier this year to say, hey, 30 million is a bit too conservative over the last few years of like discontinued performance improvements in the clients. We've built up a bit of a safety margin. Let's just push this a little bit. So there was this initial 20% bump. And there was really a strong signal that, hey, this really is something that the community is really passionate about, that we should really make a priority for the next while. So that's where we were, right? Not really changed for a long time. And then we had this first initial bump, this like sign of life that actually we have like room to grow with the throughput. And then there was a bunch of people just like exploring the idea. So like on the left, you see a blog post by Vitalik from early this year, I think it was February, where he was basically saying in the lower left column, hey, we even if we want to have the L1 be mostly used for settlement, a 10x or something is actually not a bad idea, right? Like that seems like something that baseline we should probably do. And then we had a month later, we had Dankrad a bit more aggressively saying, hey, what if we actually go like 100x, right? Like I think there's room to go this far. And then Justin, like he usually does, just came into the room and was like, you all are not excited enough, like 1,000x. He said it in like gigagas, but if you calculate, that's roughly 1,000x from where we are were at the beginning of the year. Is possible once we get to this magical technology of zero knowledge based scaling. But all of this, of course, you know, like you hear this 10x, 100x, 1,000x, and so like, what did we actually do? Like, where are we at today, right? Like bringing it back down to earth. So first of all, why is scaling even a challenge? Like, why can't we just run faster, right? So in principle, you can think of this graph, like the cost to run a full node and the throughput in the system. And Ethereum is somewhere there, like in the kind of the middle. Of course, it's relatively cheap to run an Ethereum node. You can do it on home hardware. And we have decent throughput, but not basically like where people would want us to be. And so an easy way to scale, of course, would be to just like go up the diagonal, right? Like what you can just do is you can be like, okay, now if you want to participate in Ethereum, you just have to be in a data center. And some chains do that, and there's nothing wrong with that in principle if that's kind of the use case you have in mind for your chain, but that's just not the Ethereum way, right? Ethereum wants to be this very open to everyone, robust, decentralized, trustless network, and for that, we just cannot simply increase the hardware requirements. What we did do is early this year, as part of this effort, we formalized the requirements, and you can look it up, EIP 7870. We formalized what exactly are the hardware requirements to run an Ethereum node, and that was part of what got this initial bump. But like, how do you scale this without going up the diagonal? Well, there was basically 3 phases to this. Phase 1, so just to briefly summarize, so basically like what are even the reasons why basically you have to be careful with scaling? There's, I would say, 3 buckets of things that hold the network back that you have to deal with. Live processing, being able to follow the chain as it progresses. You need bandwidth, compute, disk access there. Then cumulative, things that don't in the moment create problems, but over time, if you don't have a strategy there, become an issue. And then you have other really important parts of the network, the syncing, the transaction pool, the RPC. All of these really need to work in a very robust way. But at least for the initial kind of like getting the process started, the main bottlenecks are these like being able to follow the chain no matter what it throws at you, right? And so that's where we initially started the journey. In the short term, what did we do? Well, you can think of this image, it's more like a symbolic representation. In green, basically all the operations that are available in the Ethereum virtual machine. Like each spike basically is something you can do when you send a transaction, different operations, and they all are differently efficient. So if you use these like small spikes, Ethereum runs very smoothly. But if you use, for example, like I marked with orange, like basically the worst case operation you could use in Ethereum, if you were to like exclusively use the worst case operation, you basically push the Ethereum virtual machine to its very limit, and so that's what governs how large we can make the circle overall. So again, just a mental model, but what did we do in the early days, early this year? Well, there was this loop. You identify the current bottleneck, you optimize that current bottleneck, so now the spike is gone, and now you can scale the entire machine a little bit, right? So that's something that you can do without having to change the circle. The circles are your hardware requirements, but just running this optimization loop, getting rid of the spikes, allows you to, over time, start to slowly scale the chain in a responsible way. So that got us in July already. We got started in June again, July. So like very early on, we had this like first easy win, the first batch of performance improvements, 45 million, right? So now we're 50% above where we started the year. That's already kind of nice. And then second result, just now, if you've seen, we have the upcoming Fusaka hard fork. We're all very excited. And that comes with the default rollout of 60 million gas. So we'll soon move to 60 million gas. So now we are at double. So that's step one, right? Just performance improvements. Step two is actually changing the protocol to be more efficient. So, so for that, we have Fusaka. Fusaka helps a little bit. It gets rid of some of the worst cases. So hopefully we think that we can get to roughly 80, 120 million once that's live, and we can test that that's stable early next year. And then, much more excitingly, next year we'll have a big hard fork, Amsterdam, where scaling the L1 is really the main focus of the fork. So we have ePBS, block level access lists, and repricings. If you're more on the technical side, maybe these terms tell you something. If not, really doesn't matter so much. These are three really exciting features that all make Ethereum a bit more efficient. Specifically repricings, I just wanted to give you this, specifically, and basically the goal here would be to say, hey, you know, this Dankbarn proposal, 100x over 4 years, it's not sure that we can do that for 4 years in a row. That will be a challenge as we go further along, but for now, can we basically embark on this journey 3 times the throughput per year and see how far we can climb there. And just for repricings, I wanted to give you this quick mental model. The idea here is, right, you keep the box intact. Like, that's always the through line you should keep in mind from this presentation. The box stays intact. We are not basically like pushing into higher hardware requirements, but we basically make the most out of our available resources. And then one last slide on scaling the L1. It's just, you should keep in mind, zk-EVM is coming. zk-EVM, also very, very exciting, magical, big technology upgrade. And the big challenge that basically is at the core there is real-time proving. So zk-EVMs have been around for a while, but for Ethereum's L1 use case, you really need to get the proving time down to basically within this 12-second window that we have available in a slot. And kind of big progress this year, we actually, in the average case performance, are there now. So we have average case proving times that are about below 12, below 10 seconds even. Now, caveat, this is really just early days. Average time does not mean worst case performance. It also does not mean it's secure yet. So there's a long way to go, but as like a first step, this is really absolutely amazing progress, and the entire industry, entire ecosystem has come together to achieve this. So really, really exciting to see. Maybe, I don't know, quick round of applause for everyone working on zk-EVM. This really has been amazing. And then just to say, like, the plan here is also, like how we do things in Ethereum now, not just shoot for this like long-term goal, but also short-term, have these individual rollout stages that already allow us to use the technology once it starts to get ready. If you are interested in zk-EVM in particular, it's a really exciting topic. On Saturday, there is the ETH-proof days where you can hear much more about it. And so the hope is that with zk-EVM, we can basically we can really escape the diagonal, and we will be able to have like a very high throughput network that with a low cost of running a full node. Okay, scale blobs. And I'm running a bit short, so I'll have to really speed up a bit. Scale blobs. So what are blobs again, right? Data availability on Ethereum. Basically, the idea is that rollups on Ethereum need 2 things from the Ethereum L1. That is settlement, the ability to actually like update their state, commit back down to the L1, and also like have validity proofs, fault proofs executed on the L1. And then the other big one is data availability attestation. So you basically, as an L2, you need to be able to prove that the data that you used to advance your chain was available, because if not, there can be these edge cases where the L2 basically breaks. So it's a really important feature that was part of this rollup-centric roadmap. And initially, in the early days, what people used for this was just call data. So call data is just data you can pass into the EVM. That was an existing feature. People just, rollup operators just reuse that existing feature. That was very inefficient, because call data is meant to actually be used during EVM execution. So when you run a transaction, you execute a trade or something, the actual price for the trade, for example, comes from the data section. So it's very inefficient to pass the entire data that you don't actually need, you just want to make sure that it was available, into the EVM. So for small scale use, that was fine, but then to get beyond that, the first thing we introduced was ERP 4844, that was last year, which was proto-dunk sharding called. And the idea is simple, right? So basically, you see here the blocks of Ethereum, the kind of advancing, and now these individual transactions, right? You can see roll up red and roll up blue, basically. What they do now, they just post these normal transactions in the blocks, and they only have this little red and blue dots. These dots are called commitments, so they just point us to data, and then Ethereum just takes the data and says, we're going to make sure it's available, don't you worry. So it's a new service where you can just ask Ethereum to make sure your data is available without having to pass it into the system. And that was a big performance improvement, and how do we now check that data is available is an implementation detail. With ERP 4844, though, we still checked that the data was available by fully downloading it all. Now, what are we doing in this upcoming hard fork? Fusaka, coming in a few weeks, has this amazing feature at the very core that's called PeerDAS. What makes PeerDAS? What is the DAS in there? DAS stands for Data Availability Sampling, and that gives you the important clue. The idea here is that we make this data availability check more efficient with sampling. And we do that by taking the data, we double it, and now that we double it with erasure coding, it means that instead of having to ensure that 100% is available, we just have to make sure that 50% is available. Why? It seems silly. At first we double it, then we have to make sure that 50% is available. Why is that a big efficiency improvement? It means that now we can use probabilistic methods. If you need to make sure 100% is available, you need to download it all. There's no way around it, because the one thing you didn't check might be the one thing that was unavailable. With a 50% check, you can just sample, because if you sample often enough, you get 99.999999% guarantees. So that's secure enough to run the chain with. And so that's exactly what you do, basically. Everyone in the network now is sampling small parts of the data, and you know, now we have like multiple rows of data, and that means that in aggregate, all the nodes know that the data was available, even though they only downloaded a small part. So that's a huge efficiency improvement. And here the slide was just to show you, in reality, things are always more complicated. Like, you should not try to understand all of this unless you're already an expert in this. But the point is, actually making this work under the hood was a huge effort. Like, it took many, many months to make PeerDAS work. But the result is that as of Fusaka in a few weeks, and then we roll out the gradual increase of the throughput, we'll have much higher rate of data availability on Ethereum. Where will we go after that? The team that worked on PeerDAS is already since months, has been now actively work on the improvements for the next generation. For now, just basically like a teaser there. The idea is to say, hey, now that we have PeerDAS, like the first version of sampling, just make it more efficient in all the stages. And there's two specific stages. There's the, you send a transaction and it propagates to the network. That's the stage, that's the slow, efficient path. And then once it gets included into block, propagate it through all the nodes for sampling. And so basically both of these have individual work streams that make those much more efficient over the next year, so there will be a lot of extra scalability. And then beyond PeerDAS, the question is, will we just keep iterating, or will we have a big kind of transition to a different architecture, full dunk sharding, relay DAS? But we'll have to see about that. So that's basically, that's what the focus was in Scale the L1, right? Scale the L1, we really went from 30 million to now 60 million. We'll go to 120 and then 300, wherever we will go over the next years. 3x per year is the goal. And then PeerDAS, where we had amazing efficiency improvements that are rolling out in the coming weeks. And we have a clear path forward there, and we'll continue to give rollups all the data they need. And now, on to the last one, and Barnabé will take a little bit extra time, so not sure we have time for Q&A. I'm sorry about that. That's all my fault.
Thank you, Ansgar. All good. Hi, everyone. So let me jump in quickly. So going from 0 to 1 on improving UX meant for us at the Ethereum Foundation that we explored many directions. So these are currently active efforts at the EF. We have Interop, which is about how to improve the free flow of assets and value throughout the Ethereum ecosystem. We have $1 trillion security, which is a security-focused effort. And we have Kohaku, which is a privacy wallet that intends to put privacy as a first-class UX citizen. We're also working on something that we hope to reveal soon. In this talk, I'll focus on Interop. And when I think of Interop, there's really two issues that come to my mind. The first one is about cross-chain UX, and the second one is about the network value that comes from having free interoperability throughout the network. Let me start with cross-chain UX. I would say that this is our goal. We want seamless, secure, and permissionless experience across the Ethereum ecosystem, both for individuals and for institutions. Today, the experience on the Ethereum network is not so seamless. You may have experienced, for instance, having many different versions of the same asset on different networks. You might have bridged some tokens to a new network, and then you didn't have the right token to pay for the gas at destination. And finally, apps don't necessarily know which assets you have on which networks, and so they can't offer you seamless flows, for instance, depositing on Arbitrum using assets that are on Base. So the apps, they want to support these seamless flows so that you don't have to go to a bridge and quit the app. So we have a couple of things in the works that we plan to release. One of them is the Open Intent Framework, or OIF. It's a modular stack that is built by many contributors in the ecosystem, including the Ethereum Foundation, across LeFi, OpenZeppelin, Wonderland, Hyperlane, Arbitrum, Uniswap, Coinbase, and others. I just came back from Patagonia, where we hacked on the stack, and we made some improvements with some of its contributors and individuals. And we want to ensure that the stack addresses the needs of users, wallets, apps, and interop protocols that will engage with it. So why intents? What do they offer for cross-chain UX? Intent bridges make it easy to find liquidity where you want to transact, which means that you don't need to wait for your assets to move on the slow interop pipes. A counterparty can just front the funds for you at destination, and then you can proceed with the cross-chain transaction that you wanted to do. The OIF is modular and extensible so that different protocols can adapt it to their needs. It also offers secure modules for user and counterparty exchanges, and it allows many protocols to be routed through OIF, so it's also a bit of an interface. And finally, the OIF composes with emerging standards and the interop SDK. It makes use, for instance, of interoperable addresses, which have this human-readable form, like Barnabé.if at Arbitrum, and it runs on 7683, which is a standard for deeper liquidity and deeper markets, which means cheaper fees for users. You should reach out if you're interested to work with us on integration. A second project that we have is a new mechanism by the account abstraction team named the Ethereum Interoperability Layer, or EIL. EIL will be presented at the Trustless Conference tomorrow and on Wednesday. But you can already scan the QR code, which is on the left here, to find a post on ETH Research if you're looking for some alpha before the conference starts. So this was cross-chain UX. We are looking to fill the most glaring gaps for user experience by offering easy to integrate and modular solutions. And next, I want to talk about the network value in the context of interop and how to improve it. So what I would say is a confirmation engine is mainnet, or L1's, core service to Ethereum users and businesses, including L2s. And we must improve this service. L1 is really the beating heart of the broader Ethereum ecosystem. We want this heart to pump blood, oxygen, assets, value throughout the network, and we want the heart to beat stronger and faster. This is to the benefits of the many chains and projects that choose to build on Ethereum. So what can we do? The first thing that we're looking into is increasing the speed of the L1. So time to inclusion means how long it takes for your transaction to enter on-chain. Today, the slot time is 12 seconds, so a block is produced every 12 seconds, which means on average, when you send a transaction, you wait, let's say, 6 seconds for inclusion. This is a really long time. We can try it out together to get a sense for how long it is. I want you to count with me. 1, 2, 3, 4, 5, 6. Yeah, this is really too slow, you see? Yeah, we have to improve this. So beyond UX improvements with shorter slot times, there are also many more benefits to network value. The first one is that everything refreshes faster on-chain with shorter slot times, including prices. This leads to healthier markets, and in particular, it makes it a much stronger value proposition for DeFi. The second thing that improves with shorter slot time is interoperability with L1, which moves at the speed of the L1. So this also gets better. So here's the plan. We have 12-second slots today. We propose to move to 6-second slots. It's a very challenging engineering task, and we're actively working on this. And then further into the future, we think we should go even lower. How far can we go? This is not something we know, let's say, today, but we know that we also shouldn't risk a heart attack. So there is a limit somewhere. It's a marathon, it's not a sprint. All right, besides time to inclusion, time to finality is a metric that also matters a lot to us. What is finality? This is when Ethereum gives you the strongest confirmation that your actions on chain will never be reverted. With faster finality, we have lower capital cost across the network as assets settle faster and so they can move around. This improves UX by reducing latency and cost. We have less incentive to opt for weaker forms of settlement, and you also have more valuable network for off-chain systems that depend on Ethereum finality to know what state of Ethereum is settled. So today, the strongest finality, which is economic finality, is quite slow. It takes 13 minutes to achieve it. So we're working on a project to make available a confirmation rule that provides some degree of finality while being 95% faster than full economic finality, which confirms in a block or two. There are stronger conditions on the security, so it's not a replacement for everything, but we think there are some good use cases for this confirmation rule that can be attractive to some of the businesses on Ethereum. In particular, we'd like to talk to L2s, interior protocols, and centralized exchanges about integration of this rule. There are benefits for all of them. L2s can use a confirmed route of the L1 faster, interior protocol can do faster message passing, and centralized exchanges can reduce the delay for withdrawals and deposits. We're working to make it available in Q1 2026, so we think it's a good time to talk about it, so please reach out. So this is today's picture. Then we have our 12-second slots at the bottom, the fast confirmation rule, adding this layer of settlement, and then the full economic finality up here. Going to 6-second slots already gives us a much more responsive network. We have fast confirmation and we have finality time as well. So we have a lot more going on per unit of time. But from there, the job's not done. Our aim is to accelerate research and development for faster finality and inclusion. In particular, we want to take the finality time as it is today, between 13 and 19 minutes, all the way down to perhaps 10 seconds in the future. And you should reach out if this is an interesting challenge for you. So let's make L1 start a bit faster. Thank you. Nice.
Thank you both so much. That was awesome. Okay, so we have a ton of questions. I'm going to go from some of the more popular ones, and then we're going to go one by one. So first question. For someone new to this topic, what's the simplest way to explain why blobs matter for everyday users?
So why blobs matter? That's a very simple question. So I'm sure basically everyone here has used Ethereum, and many of you have probably used Ethereum L1, but also most of you will have used a rollup in the past. And basically for rollups, the fundamental bottleneck for how fast they can go, they have several bottlenecks, but one really important one is how quickly can they get their data availability checks from the Ethereum L1. So blobs are necessary that an L2 can basically take the latest batch of user transactions, go to the L1 and say, please, can you double check that this was actually available data? And then the L1 says, yes, looks good to me. And that can only move as fast as the rate of blobs can move. So the more we increase blobs, basically the more throughput you will get on the L2s.
Second question. What do you think of the trustless manifesto that came out this week by Vitalik, and how does that relate to some of the work that you're doing?
Yeah, we're always looking for solutions that respect properties of censorship resistance, of privacy, of open source. Like, these are criteria that are very important to us. As a personal taste, I like the word trust minimization better because there's always a model of the adversary that we have in mind. But yeah, that's all I think about it.
Awesome. Final question. How do you think about the tension between scaling L1 and scaling L2?
Yeah, that's a great question. So I think ultimately, while there is a little bit of a technical tension in a very narrow sense, so specifically on bandwidth use, there's always, you can use the bandwidth for more data for the L1 or for more data for the L2. I think that's really a complete distraction, like focusing so much on that, because most of the challenges of scaling the L1 are not on the data camp to begin with. So really these are mostly synergistic. And I think the more general point is getting to a mindset of like continuous performance improvements, and then those will naturally basically like spread across the L1 and the L2. And many of the challenges for scaling the L2s also will then be for those L2 teams within their own chains. So I really think that as an ecosystem, basically just in general, make the systems more performant, make them more efficient, while making sure we never compromise on robustness. That is a general engineering effort that will be synergistic across those two efforts.
Awesome. And as part of this, you're collaborating with teams across the board from all walks of Ethereum. How has that collaboration been, and how do you feel about it today, and how can it be better in the future?
Yeah, I mean, I think you've already seen, like in a lot of Barnabé's talk, with there's this with these intent frameworks. There's very wide ecosystem-wide collaboration. Same on scaling, especially in the ZK EVM. I'm not sure if you've paid attention to this yet. If not, either go to the event on Saturday or watch the stream or something, because it's really incredible to see the energy. There's like 20 teams that are all working on different elements of the stack. It's a very, very large kind of cross the ecosystem collaboration. Same with these other efforts, Blobs. Scale L1, I would say we're starting to also see more collaboration. Everyone in the ecosystem that has an EVM chain wants to come together on this. For now, it's a bit more of an internally focused effort.
Awesome. Final question. Is there one thing that you wish more people knew about what you do?
I wish people knew that it wasn't so hard to work on this stuff. I think people get intimidated by the complexity of a protocol, perhaps, but more and more, like we're seeing that, people are just coming up to us and asking, how do we learn to do this? How do we become like core devs or builders on Ethereum? And also, as our focus is shifting and we think more about, let's say, apps, users, and all of this, like we're also really trying to ourselves immerse into this other ecosystem. So, yeah, I think people should understand that it's much more of a revolving door between protocol and the ecosystem than it has been in the past. Yeah.
And maybe one last mention, quick shout out in our own interest. We have an amazing team at the Ethereum Foundation working on all of these different topics. If any of that sounded really interesting to you and you feel like you're like an exceptional person that could really help push that even harder, if you go to the jobs page of the Ethereum Foundation, there's an open role. Like, we don't always have roles specific to these individual efforts, but there's also an open role posting. If you feel very passionate about any of these topics, do shoot us a message and give it a try, because we're always happy to have even more people help with this effort.
And we have many internships open, actually, I think, at the moment. Yeah.
You can just do things. Thank you so much, Barnabé and Ansgar. Please give me a round of applause.